Hello, team. As we enter week 4, the requirement for additional water on the golf course has been increasing. Therefore, it is an appropriate time to begin our discussion on irrigation. The first part will describe the factors that influence water requirement, and then we will cover some strategies for applying additional water to the golf course. Let's look at some factors that influence a plant's water requirement. Let's first look at the water cycle. Water is one of the most important resources for the golf course. While water is a renewable resource, it is not unlimited. Restrictions on water use for golf courses are becoming more widespread. Therefore, regions that regularly experience periods of drought must manage their water resource carefully. So, we must develop the capability to efficiently and effectively apply additional water to our turf. We do that through understanding the factors that impact the water requirement of turf. Plant water requirement is a function of evapotranspiration rate, sometimes abbreviated ET, which is a combination of water loss through plant transpiration and evaporation of water from the soil. A main factor that influences water requirement is temperature. Similar to sweating for humans, transpiration is the name for evaporative cooling by plants. At high temperatures, the plant will cool itself by releasing water from the stomata embedded in the leaf. This process is called transpiration. Transpiration increases the plant's water requirement. If there is sufficient soil water available to the root system, the plant can cool itself without becoming drought stressed. Sustained periods of high temperatures without precipitation will deplete the available water and supplemental irrigation must be applied. A symptom of drought stress is wilt, and we will describe that condition in a few minutes. Sunlight is a factor that will amplify the temperature in which a plant is exposed. Areas that receive full sun will be warmer than areas that spend part of the day in the shade. Therefore, the plants will require additional cooling. This subsequently increases the water requirement. Looking at this diagram, the south-facing slopes of undulations on the golf course will experience more intense sunlight than their opposite north-facing slopes. So you see here in the northern hemisphere, in June and summer months, you got the sun beating down on this south-facing slope, and you're going to see more drought stress here compared to areas on the north-facing slope. Slopes in general have a greater water requirement because of runoff. Therefore, south-facing slopes are doubly dependent on additional water input. When the plant transpires, a film of water sits on the leaf blade. From here, evaporation cools the plant. Low humidity indicates a low concentration of water in the air. Naturally, molecules want to move from areas of high concentration to low concentration. And we see that in this diagram, at 20% relative humidity, this water wants to move out into the air. As we move forward in time, you're continually going to increase the relative humidity as water moves from high concentration to low concentration until you finally get to a point of saturation where the relative humidity is 100% and no more water can get into the air, so everything is mostly in equilibrium. Same is true on the leaf blade, where you have this thin film of water put there by transpiration. So in low humidity, the film of water on the leaf blade will readily enter the atmosphere. So low humidity, it's going to move from high concentration to low concentration, and the plant will therefore have to replace water to continue cooling. Now, this process will obviously increase the plant's water requirement under conditions of high humidity. This film of water is not incentivized to enter the atmosphere, and it'll stay where it is. A final factor that will act on the film of water generated by transpiration is wind. Wind will sweep the moisture off the leaf blades, and if the plant must transpire during sustained periods of high wind, the plant will be continuously replacing the water that is swept off its leaves, and water requirement will therefore increase. In summary, we can envision a worst-case scenario where the turf will require a substantial quantity of additional water. An absence of precipitation during a stretch of 90-degree days with winds exceeding 10 miles per hour, relative humidity under 30%, and minimal cloud cover will result in a high evapotransport of losses in the turf, and we must be able to supplement the turf with irrigation. Now we will apply these principles to hand watering. Our knowledge of plant transpiration helps us target areas that are likely to have a higher water requirement. We pinpoint dry spots by taking soil samples. Assessing the soil core takes some practice, but over time you'll be able to tell wet from dry. Wet soil will be soft and pliable with a dark color. If you roll a pinch of the core between your fingers, it will ball up, sort of like Play-Doh. On the other hand, dry soil will be crumbly and hard with a lighter color. If you pinch the soil core, it will likely resist and retain its shape before crumbling. Another means of determining soil moisture levels is the use of probes such as the Field Scout TDR 350. TDR stands for Time Domain Reflectometer. This meter measures volumetric water content by timing the reflection of a signal sent between two prongs that are inserted in the soil. The TDR and all measuring equipment should be calibrated before every use. You calibrate the probe by taking a soil core and a meter reading from the same spot. You assess the moisture level of the core and record the meter reading. The variable soil textures on Laurel Creek's property require that your qualitative assessments give meaning to the quantitative reading from the meter. So the meter reading should be relative to your assessment of the soil moisture. For example, we see here a soil core that I took, and this is from a dry spot, and when I stuck the meter in right next to where I took this soil core from, I got a reading of 6.5% volumetric water content. Therefore, I know that the meter is providing a reasonably accurate assessment of the soil quality. So for a little bit, I can just use the Field Scout to get a measurement, or I can continue taking soil cores and doing my visual qualitative assessments. I mentioned earlier that wilt is a symptom of drought stress. Wilt is the curling of leaf blades to close stomata and retain water. Uh, Bent grass can take on a purplish hue when it's wilting, and walking on wilted turf will leave footprints. So if you observe any of these symptoms, you definitely should take a soil core and confirm that these are dry spots and that you should be adding some additional water. So other areas that require additional water input include slopes. As I mentioned earlier, they are subject to runoff, and south-facing slopes receive more sunlight, experience higher temperatures, and therefore have higher water requirement. Additionally, Areas with a sandier soil will require more water because sand does not retain water as well as silty or clay-based soils. So areas such as this include approaches, tee boxes, and greens. And lastly, poor sprinkler coverage results in areas that have higher water requirement. So sprinkler systems are generally not 100% efficient, and we can see this here. This is a test to conduct an efficiency rating for this sprinkler system, and you can tell that there's a level of drought stress here, some drought stress over here, and some here. So these cups will indicate that not a large volume of water is reaching these areas of this putting surface, and upgrade is most likely needed to this system, or you add additional irrigation through hand watering. So we have now identified a dry spot. How do we effectively and efficiently apply water? Well, it depends. The amount of water added should be predicated on the soil's ability to hold water. From soil analysis that we send to a lab, we determine our soil texture. And typically we're in a sandy region. And that works out well because the ideal soil texture for turf grass is a sandy loam. So most places you find golf courses, you're going to have a sand-based soil. And now we look at, sandy soils, not a lot of plant available soil water in these types of soils. So how do we apply water? The best way to do so is obviously not so intensely that runoff occurs, and also we do not want to apply water so intensely that the water percolates right through the plant's root zone. So the method we employ is called multiple cycling, that we will discuss further, and this is a light and frequent application of water that is most conducive to sandy soils. So here's an example fairway. You go out with your soil probe and you identify some dry spots around the fairway. You'll also have to identify a quick coupler where you'll be plugging your hose into. So multiple cycling, going along with the strategy of applying light and frequent irrigation, you're going to plug into a quick coupler and apply water to a dry spot, maybe for 2 or 3 minutes. Then you're going to switch to your other dry spot, all within the distance of the same quick coupler. So you'll apply for 2 to 3 minutes here, 2 to 3 minutes here, and then your last in that area, apply some water to this dry spot. Then you'll rotate back around and you'll start hitting this dry spot again and this dry spot. And then you repeat the third until you can take a core sample and you see water penetrating into the root zone. So for each spot, you'll identify multiple dry spots, rotate between them, applying a little bit of water, letting it soak in, switching to a different dry spot, applying some water, let it soak in, and you continue that until you can visibly see infiltration into the root zone. And this method is going to decrease the potential for runoff and ensure infiltration into the root zone. Another thing to note are some cart path entrances and exits. These areas get really beat up, so if you have some dry spots within reach of a cart path end, it's never a bad idea to hit these high traffic areas. So the question also arises, can too much water be applied? And the answer is yes, it is possible to apply too much water. Primarily, this is the result of improper soil sampling. So you go out with a hose, and instead of taking core samples or using a TDR, you're just it looks dry, so I'm going to throw some water on it. And this is not always the best practice. So what can happen? We can get wet wilt. Wet wilt is the pore spaces of the soil filling with water and becoming anoxic, and the grass can wilt even though the soil is saturated. This is a tough thing to manage because you have grass dying. However, you can't add a ton of water. So in this tweet, you'll see wet wilt has been occurring, and this consultant recommends syringing. So you're applying very little water to kind of just help that area survive what it's going through without exacerbating the saturation conditions. And then also there's a situation called scald, where standing water, if it exceeds 100 degrees Fahrenheit, the root system essentially boils and the grass will die on top. So applying too much water is possible, and we want to just make sure that we sample appropriately and apply water appropriately. If you regularly find a dry spot that doesn't make sense, in that the area is not sloped or weather patterns don't indicate the need for an increased water requirement, then the issue may be caused by a sprinkler problem. Typically, uniform stress has a mechanical cause, and this picture is an extreme example of that. However, illustrates how you see these fairly uniform patches of green grass, then you can clearly identify that the reason the rest of this stand is struggling is it's not being covered by the sprinklers as intended. So sprinkler arcs out of adjustment, sprinklers not rotating, or the sprinkler not running at all are all going to result in uniform patterns of drought stress on the golf course. And if you happen to notice this or identify this, that's something we would want to know about so that we can address the problem. Some other notes that will be covered in more depth during your on-the-job training. When you go out to hand water, make sure you have all your equipment prior to leaving the shop. That includes your hose, the quick coupler, nozzles, and a soil probe at the very least. Sometimes you'll go out with the TDR moisture meter or some wetting agent. For turf health and equipment longevity, we're not going to be dragging hoses around the golf course. Additionally, once you have your hose locked into the quick coupler attachment, any tension on that is going to put a lot of strain on the joints and could cause a geyser and that attachment to blow out of the ground, and that's a big cleanup project. So the irrigation system is under constant pressure at about 115 psi, so any unwanted stress on joints will be problematic. By the same token, you want to release pressure on the hose prior to removing the quick coupler from its position. So this means make sure the nozzle is open and releasing water so that you don't get a back pressure when you take the quick coupler out of the ground. Your trainer will describe this, and hopefully it doesn't happen on your first time. Lastly, just like we talked about before with any meters, you want to make sure you calibrate as necessary. That concludes part 1 of irrigation. Irrigation part 2 will cover irrigation systems and the role of the irrigation technician. As always, any questions, please feel free to reach out, and let's have a great week.